fraction of a second. It's pretty impressive to watch, actually. Okay, there we go. I can just use the other side. Let me just do this. There you go.
I always have the problem when I do accidentally close other parts of the phone.
Yeah, exactly. That's why I'm keeping my finger here.
Yeah.
So once one part is open, it doesn't open again.
But I'm main about it. I'll use the tool.
You can see that the phone still works, so I'm just going to turn it off. Okay, so
It's still on,
yeah.
but for now,
It's actually kind of cool to see the LCD, the LED back panel turned on. I can't turn it off right now until it finishes turning itself on. But I should be okay to disconnect. What I'll do here is I'm going to disconnect the. Are you guys okay to see this?
Yeah.
I'm going to disconnect the fingerprint sensor, which is just disconnected right here. So now the back portion and the front portion are disconnected. And we're doing this phone has not been previously torn down at all. So you can see right here, the two safety stickers are on, right? So obviously once I take out those screws, you won't be able to see the MI anymore. Do you want to sit a bit closer? Do you want to sit a bit closer? I'm prioritizing the cameras here. Okay, so I'm going to start with the fingerprint sensor. So capacitive based fingerprint sensor, right? So this is stuff that you'd expect. What people don't really know is how thin and how actually small the fingerprint sensor. So I'm actually going to peel off this protective layer here. And I'm not sure if I'll be able to do this super gracefully, but I'll try my best. So what this will do is it will reveal the actual fingerprint sensor. There's a way to do this that it just comes out. There you go. So I'm just going to peel this off. Obviously, the fingerprint sensor is it's not a serviceable component. If you need to replace it, you just replace it. You don't repair it. So this is why this axis is quote unquote destructive, in the sense that you have to put a whole sticker again on top of it. What you notice about some of these stickers is that they are used for heat dissipation. So they will have dual surfaces. On one side it'll be metallic, on the other side it'll be more carbon-like. I'll show you that in a bit. What I'll do here is I'll peel it around the fingerprint sensor. And all I have to do is just push it. And the fingerprint sensor actually comes out. Needless to say, what I'm already doing here is non-reversible. Obviously, it just requires so I'm going to peel this off. And what I'm going to put right here, this is the fingerprint sensor right there. So it's very, very thin. This is about maybe 0.5 millimeter thick. And it's a very simple surface. It's basically a metal capacitive surface. And the controller chip for the fingerprint sensor is actually right here. Right? So this is enough to carry all of the essential activities for it. To be clear, none of the actual fingerprint unlocking functionality is in here. Right? This is just controlling, detecting, for example, when you touch the surface, so that it can do so in a very power efficient manner. The actual fingerprints are stored inside of the SoC, right? Inside of in a secure area of the chipset itself. So that's the fingerprint sensor. I'm just going to sit it right there. And this on the end here is just a connector to the PCB. All right. So I'm going to focus on this guy for a second. Can you finish building it off for me? So, all right, so now let's focus on the main part of the phone. If you want to see this here as well, welcome to play with it. Okay, so a few important things to emphasize here. First of all, as you guys would have remembered from the Mi 4i teardown, the goal of the internal design is to maximize empty space, because then we can fill the empty space with battery. So we did that with the PCB, and the PCB design probably takes half of the initial R&D effort in terms of number of hours, because everything you do requires a change to the PCB. And then you have to recut it and have another prototype made and so on and so forth, and then test it. Every component that's placed on the PCB affects every other component, because there's just a tremendous amount of electromagnetic influence between components. So you have to basically make your PCB and you have to test it and then make it again and test it and so on and so forth. I'll come back to the PCB in a bit. Probably one of the most fascinating bits about Redmi Note 3 inside, this is something that you would only have seen if you've done a teardown of a flagship device, is this antenna. So there's no physical structure inside. That's the antenna on Redmi Note 3. This is the first Redmi series device that we're doing with what's called an LDS antenna. LDS stands for laser direct structuring. I always just say LDS. So instead of having a physical structure, that's the antenna is actually printed on this bottom plastic board, meaning the pattern that you see here, this goldish, silverish area, that's the actual main antenna itself, right? It's actually very interesting. It looks funky with all these weird curves. This is a precisely determined shape that is specific to the LTE bands that you're trying to support, right? So this is different from a device, for example, that we launch in other markets. The way this is done is obviously the design is done in the lab with a lot of testing, but the final manufacturing process is you have a laser that essentially sensitizes the surface of the plastic, and it obviously moves it around in 3 dimensions. And then after you've sensitized the surface of the plastic, you then come in with a coat of essentially a metallic paint that will only adhere to the area that was previously sensitized by the laser, right? So this is why it's called laser direct structuring. And so it's kind of like a 3D antenna that's printed on top of this plastic board that would normally be used for nothing, right? It's just covering the sub PCB, which is at the bottom of the device. If you look on the other side, you see 2 other things here that look the same. So these are 2 additional antennas. One is used for GPS, one is used for Wi-Fi. This is a Wi-Fi AC 802.11 AC device, so the antenna design has to be perfect in order for you to get that kind of throughput that you would need. Right, so this is a really interesting thing, and most people would open this and they would have no idea what this is because you couldn't possibly guess that this is an antenna. Right, so that's the LDS antenna. Something else that I would mention, coming back briefly to the other side of the device, is that the 2 ends of the metal body here are actually made of plastic. Right, and this is precisely because they cover the antenna, right? So the antenna should not ideally be behind metal. I mean, it creates much worse reception. So the antenna is actually behind a very narrow plastic area, right? But it looks like metal, of course, from the side, from outside. So now what I'm going to do is I'm going to start the teardown per se. I'm going to take out the main PCB first. Yeah, actually I might as well take out the sub PCB. So the sub PCB is this piece here on the bottom. I'm using the proper tool so the screws just stick to the screwdriver. It's a magnetized screwdriver. So let's take them out. I think there are 3 of them here. We really could have used better lighting, I think. There's a possibility of moving over there if you guys want to consider it to the white table. I'm happy to start over if you want.
No, I think we can.
Yeah?
So I could have tried to catch us.
You can always do it again. I played it too. Okay, so I'm going to take out this bottom board here. No, there's one more screw. I forgot. Okay, so then I'm going to take this out. So this is what's called, like I said, the sub PCB. And what it's covering is, not only does it house the antenna, which I've shown you guys before, which is that part, but it basically just covers the bottom part of the device. So what you have here is essentially your charging circuit, your USB data transfer circuit as well. Here's the USB port, and of course this is also where the speaker is located, so that the circuitry that is responsible for the speaker is all built in here onto this little piece. So now I'm going to take apart the PCB. I'm first of all going to take out this top piece. So that's the top board, and you can see again the antenna design that I mentioned earlier. You can see it right there. Right, one is GPS, one is Wi-Fi. Right, so that's essentially the entire Wi-Fi and GPS antennas. It's just that piece over there. Okay, now I have several different screws to take out here from the PCB.
Have you disconnected the battery yet?
I have not disconnected the battery yet. Probably a good idea to do that now, isn't it? So the battery is connected right here. There you go. Battery is now disconnected. Thanks, Roger. Okay.
Tightly packed everything in it.
Yeah. It's just a small sticker there. That shouldn't be a problem. Okay, I'm going to disconnect. This is the RF cable. This actually connects the antenna. All parts of the antenna, I believe. There's one more screw right there. I'm going to take out as well. There we go. And so now what I'm going to do is the following. I've taken out all the screws. I'm now going to just take these connectors out. So let's connect them one by one. This one connection just hit right now. So I'm just essentially pulling out these connectors. Oh, that's the front camera. I'm going to disconnect the rear camera. I'm going to disconnect this guy here as well. There you go. Okay, and then out comes. All right. So here's the PCB of Redmi Note 3. You can see how insanely compact it is. Like I said, when you're designing a PCB, basically every component has to be thought through in conjunction with all the others because they all influence each other, right? So it's a very complicated design process, especially if you want to pack everything together. And this is probably one of the things that we've gotten the best at over the last couple of years, is really our PCB design. It's a double-sided PCB, so you can see one side here. So that's one side of the PCB. And I can turn it around. The other side, right now you don't see much because there's a couple of protection layers in here, which I'll talk about in a second. So what you see here in black or dark brown, this is a heat dissipation layer. The processor is in here. That's the part that gets hottest, of course. And this is a dual-sided material, a dual-sided layer. On one side you have copper, and you'll see it looks kind of orange when I take it out. On the other side you have a nanocarbon surface.
Right.
The copper basically helps spread whereas the nanocarbon helps push it out, right? So I'm gonna pull it out here. So you see the copper over there? So that's the copper, that's the nanocarbon. So this is also a non-reversible process without having another one of these that I can replace it with. I'm just going to take the camera out. So this is the camera. You can see it right here. That's the rear camera, all of it. And this is a standard mounted camera. There's no OIS technology on Redmi Note 3, but it's still fairly compact. So I'll put that aside here. And I'll go back to peeling out this surface. So you can see me peeling out here, and you can see the copper surface. I pull it out. And then what you'll see below the this heat dissipation layer is that all of the components on this side of the motherboard have an electromagnetic shield on them. It's extremely important to keep them isolated to avoid interference that could cause some of these components to not perform as they're intended to, or not perform at the optimal levels. So these components are generally either serviceable or non-serviceable. The ones that are serviceable, of course, have technique to get to them, which may not be the technique that I'm using. But the idea is that some of these shields you are able to actually remove if you pull them out in the right place and service the component. Others you just don't. Meaning, if whatever is below is malfunctioning, like the processor, for example, you just replace the whole motherboard, right? Again, you can see how compact this is. The processor is right in here. It's right underneath this cover, which we can also try to take out. So processor, memory, and RF is what's on this side of the PCB. That's the back side. And that's the front side of the PCB. It's super, super compact. So I'll put that on the side here. Okay, now let's go back to the main body of the device. Now I'm going to take the battery out. The battery has an interesting, taking it out was interesting. I kind of suffered the first time around until I learned how it works. So the battery is actually glued with a special kind of glue to the back of the device, and you see there's two little black areas right there. So that's the glue section. And the way that this glue works, if you can bring me one of those, it's actually very interesting. So basically you have, it's a glue that is very, very resistant in one direction, but not in the other. So here you can see an unused piece, and I'll pull it out. The area that you're seeing is just this end here. But it basically, it does not move this way, but you can actually, meaning it glues perfectly and it will not resist any movement in this way, or pulling it out. But you can actually pull it straight out, and it comes out beautifully. So let me just show you this. Hopefully it'll work. All right. There you go.
Should grow your nails out for these product launches.
I know, seriously. Uh-oh. I think I may have damaged this one, but we'll give it a try. Huh.
Try these guys.
No, I've potentially okay, well I think I did the wrong thing on this one. I'm gonna try the other side. So watch me pull this out. Cool, right?
Yep.
So this is like a really, really solid glue, and it just comes out. The other side didn't come out, so I'm going to have to either try to fish it out, or we're going to have to use a little bit of brute force on this one. Let me see if I can fish it out. Ah!
That other guy's much better at it than you are.
Oh, thanks, Jay.
Just thought I should point it out.
Whoa.
Whoa.
That may not be very good. Anyways, I'm gonna just take it out without worrying too much about the glue. Right. So this would have been a pretty seamless process had it not been for my not pulling it out correctly. Right. So so here's the battery, and this is obviously packaged as an internal component. So this battery is not meant to be taken out and or serviced by users, if you will. Now, what's interesting is if you compare this battery with the battery for
Expand it.
yeah. If you compare the battery for Redmi Note 3, which is right here,
Yep.
see how thin it is, right? I have a Redmi Note battery here. This is 3,200 if I'm not mistaken. Yeah, 3,200 typical. So 4,050, 3,200. And look at the difference. And put this on top of the Redmi Note battery. And it's even more interesting when you compare the thickness, right? This Redmi Note battery is clearly thicker than the Redmi Note 3. We're using a high density battery with Redmi Note 3. This is about 690 kilowatt-hour liters.
No kilo. What hour liter?
Watt-hour liters. Sorry, 690 watt-hour liters. I always get that metric wrong. Which is the same technology that we've used in Mi 4i as well as Mi 5, right? So it's the highest density battery technology that's available in the market. And then we've gone to extremes.
It's quite cool to actually see it.
Oh, I see.
Yeah.
Yeah, so this is what happens if I had pulled it out correctly. So it's almost like it goes line by line as if it were a plotter.
It's like a thread.
Yeah. All right, it just comes out. And you saw how hard I had to pull
Yeah.
to force it out, right? So it's pretty cool. And we've gone to the extremes to try to make as much room for the battery. So if you look at the metal body of the device, you can see that there's an indent that we've created here in this area to really try to push the battery as far towards the back of the device as possible, right? That may have gotten us the extra 100 mAh, for example.
Mm-hmm.
All right, then the next step in the teardown would require a heating gun, which we don't have here. But what I would be able to do is actually take out the display, right? So basically there's glue around the corner here, and it's like that for every device, but magically with the right temperature and applied in the right way, the glue just essentially disappears. But what I have here is what this would look like when separated. So this is essentially just the structure where everything sits on, you know, the battery, the PCB, and so on and so forth. This one is not colored. This is just raw plastic, and then this particular assembly comes right on top. Right, that includes what you see here. This is the LED area. Right, the LEDs obviously are on the sides, but it's how the light gets dissipated in a somewhat even fashion behind the LCD display, and then right below it is the LCD display in the glass. Right, so everything is in this one assembly that you see here. These cannot be separated. In fact, the part is this. You can separate, actually you can separate the glass, but you can't separate the LED from the LCD. So this just goes, and it's actually pretty cool that the LED dissipation thing is this mirror-like surface. I don't actually know why. It's like this.
Oh, yeah, it just looks cool. That's probably
Probably.
probably the technical reason, I think. Looks cool.
That was very helpful, Jay. Thank you.
Yeah. That's what I'm here for.
Excellent. Adding value everywhere. What else? One thing that I love about Redmi Note 3, which I didn't get to talk about on stage yesterday, is actually the vibration motor. We have a really good vibration motor on Redmi Note 3. The purpose is to do more than just the vibration when there's a text message or when there's a phone call. It's to give a much finer sort of haptic feel. You can notice this particularly on the SwiftKey keyboard. We set, I think, the standard vibration, which is set default to light on this device at around, I think, 6 or 7 milliseconds. So it's actually fairly small, but it's a really nice, very kind of discreet little kick. And it's because of this motor, right? This is a really high quality vibration motor. And the body of the device, of course, also helps, being metallic. And then the last thing that I would point out, another detail, is if you look at the back, the metal body of the device, on the inside, you'll see these small little black cushions right here. So these are actually exactly aligned with the connectors on the PCB. Basically, wherever there is a connector coming in from another part of the PCB or from the device itself, these cushions essentially press those connectors shut. Just in case, for some reason, maybe the body displaces a little bit, or it dilates, changes size or whatever because of temperature variation, there's a pressure that's applied to the connectors to make sure that they stay connected. Or maybe if your phone drops, the connector could accidentally go loose, but that doesn't happen because of these cushions. So it's not necessarily super high tech, but it's attention to detail, right, to add these little cushions. And then there's these metallic pins around the device. There are throughout. This is essentially helping ground the PCB at the right components to be more resistant to electrostatic discharges. And then the other thing that I would mention is these cushions over here. They're like metallic cushions. These are essentially attaching to the antenna itself, so you can actually use the body of the device for extending the range of your antenna. But the core part of the antenna, which I showed you earlier, is the LDS antenna, which is over here. But we're using the body of the device, since it's metallic, except for the very top and bottom parts, to expand the efficiency of the antenna. Beyond this, I could of course go sub-atom level here and take out the different protectors of the PCB, but that's going to take quite a bit of time. So we can do that offline. But this is Redmi Note 3. And now Jay's going to put it back together.
Sure.
All right, go for it, man.
All right. Well, you take this. I have no idea how to put it back together.
Because I'm going to do it.
Can you put the glue thing?
If you're going to try?
Yeah, you use experience.
Can we try putting the glue back?
Ah, sure.
Try it out. Yeah.
Yeah.
Kept the spares.
Yeah, so that.
The spares are right on the table.
Wait, did you break the battery?
No, you broke the other one.
Oh. You gave me a broken battery. How was I supposed to put it back together? Here's this
Okay, so yeah.
Oh, but this one's also.
Yeah, you won't be able to put it back.
Yeah, so the way we do it is very simple. Just follow the guideline. Oops.
Did you put it on backwards?
Pretty sure this is right.
I guess we'll find out. I've never actually seen that. Have you ever put the glue back on? I've never seen it.
Or maybe we actually put it on the surface of the battery instead? Could that be the case?
This way. Correct. This one's broken.
Okay,
So.
try another one.
Well, both batteries technically are broken. This one ripped. Actually, potentially dangerous. So.
For the black part, the
No, wait.
sticky part has to be facing up.
Huh?
Just don't
Because
carry it
you're
in the
going to
flight.
fold it back down onto the battery, right?
It's black on both sides, isn't it? I don't know. There we go. Yeah, it's gonna fold back up like
fold
this.
back,
Yeah, so I guess the way this works, I'm sure that there's a thing that allows you to align it all perfectly. So what I'm going to do here is I'm just going to lay it down there, and I'm going to use that as my guide.
What?
Hmm?
I'm just saying that's cool. I mean like you're doing it incorrectly.
And then pull it out.
Huh. It's more or less okay,
Yeah.
I guess. I'll just take it out from here. Wow. Look at that.
Don't you want to attach the other one?
No,
The other one's like,
it's all right.
Nah.
Pull it out again. Whoa, look at
Yeah.
that.
Yeah.
I like how they designed glue to come out cleanly, I was gonna say.
Anyways, before we make more of a mess, this is the end of the tear down, and then Jay's going to do the tear up now, off camera.
So last time when we met for the